Good morning, everybody. Can you hear me well? Very good. Great to see so many people at 9 a.m. in the morning. I know from my own experience, a night out in Berlin to meet next day 9 a.m. it can be sometimes tough. But thank you very much for your time this morning. As in my introduction, it was already mentioned, a lot of people see the sec in DevSecOps as an additional burden, a new buzzword. It's not created by myself or by our company. I think it's a term used in the industry. But I talked to a lot of folks yesterday here in the audience, and I think everybody has an understanding that security in software development, however it is organized, is still a crucial and becoming a more and more important topic. So I just want to run you through some general thoughts today on how it is, in my opinion, the only possible way to keep the burden as small as possible and make it happen at the end of the day to develop secured software in DevOps environment. Just to start out some general terminologies, the industry created a new term, what they call software exposure. Because in the DevOps world, a lot of the traditional approaches, you know from your own experience in developing software, but also in securing software, have to be defined completely from scratch, because the phased approaches simply do not work any longer. Just to give you some numbers, like Amazon, I'm not sure if they're really true, I got them from the media. They deploy like every 11.6 seconds. Facebook, deploys 50 to 60,000 times a day. That's tremendous numbers. I think most of your organizations are by far away from that. But at the end of the day, software architectures are changing away from the monolithic architectures towards microservices, towards open source components, and the speed of delivery is increasing dramatically. And this leads to the term what the industry today calls software exposure. How can you be able to manage the risk in your software exposure? And this is pretty much what it is all about. And there's certainly 4 areas to address. First of all, it is code exposure. Are you able to identify the really critical issues in your own code, but also in potentially used open source components? Secondly, remediation. Do you have processes, technologies whatsoever in place that allow you to prioritize and remediate those efficiently in the given time and budget? Adoption, of course, is supposed to describe, are you able to automate and integrate this in your complete CI/CD pipeline chain? Because manual interaction in a continuous test process simply doesn't work any longer. And last but not least, also software enablement, or some people simply call it training, is a very important and crucial factor. Do you have insight? Do you know that your developers have a solid understanding for secure coding in the first place, in the respective programming languages that you are using in your environment? Make sense? I think it's not rocket science, the whole thing. And what has proven to really be efficient is a 5-phased approach, rather than picking technologies as organizations did in the past and try to get them to work. Today it makes more sense really to drive this towards a holistic approach. First of all, define what you want to accomplish. Every organization develop certain types of software projects. Some are mission critical, some are medium to low risk. So first of all, it's important to understand what risk are you willing to take for those individual types of software projects that you're developing. So define policies, because it's important to have an understanding what do you want to accomplish at the end of the day before you even get started. I see it personally also as a handshake or a contract between the security folks in your organizations and your development teams. Because if both have agreed on deliverables before they start, it is much easier to accomplish those goals rather than having the developers write their code, and at a certain point the security auditors come into place and prove them there's a ton of findings that they need to go out or go back and fix, and they don't have the time and the budget to do so. Also, to agree on a certain knowledge level, training level, is also part of the definition process. Makes definitely sense. Then when it comes to I just call it the identify steps. The identify phase, you may be using technologies that allow you automatically identify security vulnerabilities. I'm very sure most of you are familiar with the terminologies like static application security testing. I'm using the Gartner terminologies, SAST, software composition analysis, or a lot of folks call it OSA, open source analysis. Do you have insight automatically get feedback? Are the security or the open source components I'm using, do they have vulnerabilities inside? And if yes, what to do about it? And last but not least, dynamic testing. Then it makes sense if you're using different automated security assessment technologies to drive synergies or correlations between them. Because at the end of the day, the most critical factor, as I said before, is remediation. How can you get to remediate intelligently what is needed? And last but not least, the monitor is basically to control and manage what your team is doing. Just to give you a few insights, the policy management, as I said, define what risk level are you willing to take for your individual high, medium, and low software development projects. Open source, for example, also a very important part in the policies. If you're using open source components that oblige you to put your own code also open source, this may be something you do not want to do. So this is also, for example, a policy that you should define right in the first place to avoid any confusion afterwards. So you should be able really to see what's going on, have a clear understanding, a handshake between security and the development teams right in the first place to start off. When it comes to static assessments, the identifier layer, static code assessments may be painful. You need to choose a technology that allows you to support whatever programming languages you're using. But it needs to be a very flexible thing that allows you to choose the right compliance or governance framework that you're needing, being it OWASP, HIPAA, PCI, whatsoever. There's a ton out in the market. It should be a technology that allows you really to run it as smoothly as possible, because static code analysis, who are the main users of it? It's going to be you, your developers. Your developers are the core person. Therefore, it needs to be as supportive as it can for your developers. It should be able to scan really, literally speaking, from the first line of code. Developers don't want to wait till code is compilable and you scan after months. It needs to allow them to identify vulnerabilities as early as possible. It should be fully integratable in their work environment, in their IDEs. Clearly showing them in this 5 or 10 lines of code there is a vulnerability or potential vulnerability detected with a clear explanation that they can understand why the technology has classified this as a vulnerability. For example, there's coming a value, a data value in this software string or in this data flow. It's not validated or sanitized. It's running through and ends up in a database not being sanitized. Of course, this is a clear vulnerability. And then, of course, best support on how to remediate it. General remediation advice, CW is probably the common weakness. Enumeration database, pretty much everybody knows here in the audience, I'm pretty sure. But this is not enough for developers. It's far too complex, far too time consuming. So they really need efficient guidance on how to fix this individual type of vulnerability in their respective programming languages. So there is various opportunities how this can be best supported. Also technologies that go a step further, analyzing is there interdependencies between vulnerabilities, for example. As in this graph tree, certain technologies allow really to analyze if there is interdependencies and points the developer to something where they can get the most out of with the least amount of remediation effort. Fix one vulnerability and get rid of all subsequent one. Very important also, technologies to allow the developer to rescan. Was my individual fix successful? Some call it a delta scan or incremental scan. Developers want feedback in minutes and not wait another 3 days until the technology or the process chain has identified, no, your fix was not successful. They want to get feedback immediately before they check it back in. Open source components, as said, simple approach, software composition analyzes, identify clearly what open source components you're using, in what version. Do they include any vulnerabilities? And if yes, provide clear guidance on how to get this issue solved. That might be just updating the used component to the most actual version or whatsoever, because you're not going to go and fix any open source components. But you need to make sure that what you're using is secured as much as possible. And of course, does it comply with the legal terms and compliance guidelines in your organizations? The dynamic testing, a lot of organizations still have to rely on penetration testing, but penetration testing, a clear-faced manual approach is a good thing to do, but simply does not scale and does not allow any automation in the DevOps world. Similar apply to DAST, or dynamic application security testing. This has also been proven not really being capable of being automated in the Agile DevOps world. RASP, runtime application self-protection, similar thing. And it runs really in the production world. It's not really part of a DevOps cycle. But what has been proven, and if you look at Forrester, Gartner, IDC, they all predict that what they call IAST, interactive application security testing, is most likely going to solve this issue. Because IAST, I'm not sure if anybody has heard about it, it does not require a separate individual security step. As a passive setup technology, it allows to identify vulnerabilities in your integration or functional test steps that most organizations are running anyway, either being it a manual test process or being it automatic, using like Quick Test Professional, Tricentis, whatever technologies you're using in your organizations with automated test scripts, testing your application for functionality. An IaaS technology instruments the application server, sits in the application, monitors the traffic going through the application on that level, being able to identify potential security vulnerabilities, and in the background even decompiling the application, allowing to show the vulnerabilities back again in terms of lines of code. Because this is the most easiest way to get it back to the developers, rather than just pointing them to JSP pages or such thing, where they spend hours or days to discuss and find out where the detailed area of the problem is. Line of code, show them clearly this 5 lines of code, have this type of vulnerability, go back and fix it, please. So this is basically, as of today, there is potentially in the future more automated security test technologies coming into place. But today it is static assessment, dynamic assessment, and software composition analyzers or open source analyzers. Next part, of course, if you're using various automated test technologies, how can you get the most out of it? I think the keynote yesterday was silos are dead, long live the silos. I don't see it the same way. I think silos are going to die, because just having people doing static assessment and on the other end of your organization having somebody doing some kind of dynamic test does not really work. It needs to go hand in hand. Therefore, for example, direct correlation between static and dynamic findings to increase the confidence in the findings you're having. Because if you identify a security bug or vulnerability statically, and you verify it on the dynamic side in the running test application, you can be sure this is 100% a true positive. you can move it to the top of your priority list. Other synergies are allowing, for example, I wouldn't call it correlation, but between static and open source, for example. If you have a direct connection here, rather than having individual teams testing it, if it goes hand in hand, it gives you much more insight, much more value at the end of the day, and trust in what you're finding. Because in the DevOps world, everything needs to go hand in hand. You need to start training your people at a certain point. Security assessments, the painful they are. Nobody really likes security testing, but still it's important. As long as your software is fulfilling mission-critical things, it is important to make sure that also the security layer is up to date and works properly. Therefore, of course, full integration and automation across the CI/CD pipeline, the SDLC, however you call it, is essential. Starts with the development environment of your development tools, the source repositories, the build management, the scan automation, up to the test environment. This is where these technologies need to go hand in hand to make it successful and deliver a productive outcome. Does it make sense so far? I don't hear no, which is good. So I heard something, the pre-decent talk about AI. I hear AI so much, but it's a very important thing, even so I don't like the terminology of AI. But attackers, if I'm very closely investigating on current security research, and a lot of attackers these days seem to involve AI or machine learning more and more. And therefore, on the defender side, it's also very important to use and leverage these type of technologies to make sure that you can keep up to date. Because when it comes to remediation, I think intelligent remediation becomes more and more important in an organization. And that starts, of course, with machine learning capabilities, because you do not want for each and every development project that you are starting to reinvent the wheel from scratch. So if you have a technology platform that allows you to remember what your team, your organization, or part of the organization have been doing in the past in dealing with certain types of vulnerabilities, and starting to learn and implement this for the future automatically, this is a very important step. And then, of course, bringing together in the next phase, results that you generated from using different automated security test technologies, like static dynamics, static open source. Bring them together. All kinds of synergies or correlations that you can generate can help you to increase the priority, or helps you prioritizing the type of findings. Then again, mapping it with the originally defined policies. Are there any policy violations? Yes. Then it's clearly putting things up in the priority list, because at the end you need a prioritization engine. Practically, security tests typically generate more findings than you will ever be able to solve. Therefore, it's important to understand how much risk you're willing to take, and what are the top 10, 20, 50% of the found things, because your teams won't be able to resolve 100% typically, but if they only, due to time, budget, resources, whatsoever, able to resolve 30%, they need to be ensured that the technology points them right to the most important 30% of your total findings. Make sense? So bringing this all together, as I said, developer enablement, I'm repeating, it is also an important thing. We've seen developers that have a basic understanding on secure coding. I know developers don't like 4-hour training sessions. There are other ways in the market, gamified approaches, technologies that allow them to run their trainings whenever they want, 24/7, if they wish, 3 a.m. in the morning. No problem. But give you in an organization also the feedback about the knowledge level of your development teams. Did they pass the little test? Did they encounter the challenges they were supposed to do? At the end of the day, of course, when it comes all together, this is more a management topic, but you want to see also what's going on in your organization, in your individual software development projects. First of all, that the training level, for example, is present. What is the status of the security findings? Have they been covered? Are they addressed? Do you see trends over time where the amount of findings is decreasing and going down? Because you want to see and manage what you have defined in the first place. Are you accomplishing this over time? I think this is one part of the equation is good technologies. These technologies you have to choose for your individual environments. But keep in mind, and I think you will encounter and find out yourself very quickly, at the end it needs to be a technology approach that allows you to drive most efficient synergies from the different approaches you are taking, technology-wise. Because if everybody works in silos and nobody really talks to each other, the outcome will be far less than if you have an automated, holistic approach that allows to drive intelligent remediation. Besides the technology side, it is very important also, do not forget the people. Because at the end of the day, it's not security auditors working with these technologies. It needs to become an automated process which runs more or less with as little input from the outside. Therefore, the process side of the equation is very important as well. And to keep it simple, we have seen when I'm around in the market for almost 10 years, specifically in the application security part. And when I started in this business, it was a very common thing. I was only talking to security auditors. There were like 9 to 18 months software development projects. After whatever, 6 to 12 months, the first security tests were planned. Then the auditors produced nice reports. They were up to how many findings they could. They wanted to find as much as possible, which is crazy. Because at the end of the day, do you find what is important really? What is really risky for your application, and can you fix it in the given time and budget? And this has changed now when it became agile and now the fully automated DevOps process side. So a two-phased approach. On the left-hand side, I just call it a kickstart. Somebody, before it's handed to the actual users, to the developers, the whole technology need to be tweaked just to provide reliable results. Because as you can imagine, if a developer gets 10 findings and 9 of them are questionable to him, or he sees them as what people call false positives, he says, leave me alone, this is never gonna work. It's dead. It needs to be vice versa. 9 out of 10 need to be really relevant, and if there's one in there which may be questionable, developers can fix it, because fixing an issue is not going to days or weeks of work. It's usually minutes to hours. So the kickstart phase is basically to make sure that, first of all, the quality of findings is proper, solid, and relevant. And then setting up everything from integration and automation that when it's handed over to the continuous improvement cycle, where it runs in a fully automated self-sufficient mode, everything is set up properly. But to do so, to manage this agile process, you need some expertise. And either an organization has the resources and the capability to build this knowledge and process know-how themselves to support the development teams, or what we see in the market more and more often, in the past, it was organizations providing managed services. Simply speaking, give us your code, we assess it for you, and we give you back a report. As you can imagine, in the agile DevOps world, this is not working any longer. So what we see is really something more like a hybrid delivery. First of all, most organizations see their code as their intellectual property, IP. It cannot leave the premises. In a lot of large organizations, It still needs to sit in their data center, not going anywhere. Smaller, more agile organizations doing their business models in the cloud, for example, they may run it in a cloud-based setup whatsoever, it doesn't matter. A hybrid delivery is having a technology stack in a similar way as described, but having external expertise to run and help the development teams to undergo this two-phased approach to make things really smooth and happen automatically afterwards. This is where this is a proper setup which allows really organizations to ramp up in a broader scale and a larger scale their application security program to allow not just having 5% or 10% of their application landscape in such an AppSec program, rather than having several hundred in the first year to start out with. So really to deal with a vast amount of software projects, because a lot of organizations are having tons of developers. Software is everywhere. Software is becoming more and more important in all new business models, being it in finance, in retail, in industry, in technology. This was pretty much it. Just a few sentences at the end about where I'm from. Check marks, I'm not sure who has heard about the company. We are an Israeli company, almost 15 years in the market, and we are one of the fastest growing technology, software and services house worldwide with close to 600 employees as of today, growing 60 to 70% year over year. If you're interested in discussing in more detail, feel free. We have a little booth out in the atrium. We will be here all day. Just drop by, and we are happy to answer all of your questions. But if there's any questions as of right now, I'm happy to answer them straight away.